Hey everybody. You can see on the screen, I'm going to work through how to simplify a rational expression. In this case, we're going to talk about adding rationals. Now, we may need a new method. I put that in green on the bottom. I've gone through and dealt with a video where we ended up adding together two fractions. And I wanted to provide an alternate way to go through and add those fractions. That is, if we can just take a look at that blue expression, and if you can see through lowest common multiple that your common denominator is going to be 18, well, great. Or if you could just go through and multiply those two denominators together and get a 54, and then change the tops and simplify, great. But I don't think that that method is going to work quite the same way when we get into rational expressions. And so my challenge to you today might be, does your method that you use for blue apply to the white? And I want to walk through maybe an alternate way, which is, if we've been going through and adding fractions and we've had no difficulty, how does that same method apply to rational expressions? And do we need a new method? So I want to jump in and I want to play through that white solution, that rational expression solution, using the same methodology. Here we go. So I'm going to go through really quickly. If I was to take a look at that expression and have to simplify it, and I was to, let's say, reflex into an old method. Well, one of those old methods then might have been, well, I know I can always get a common denominator by multiplying together my two denominators. Now, when we go through and we do that, we're going to get a pretty ugly denominator. I'm not going to expand it because I want to keep it in factored form in case it simplifies later. The unfortunate part, look how small I've made my fraction line, and we'll notice, yikes, I think I need to make that a little longer because look how ugly that numerator becomes. For me to go through and change my one denominator, I have to make sure I change my top the same way. I do that within both tops. When I now go through and expand that numerator, well, in my first term, I'm going to get an x cubed. I can then multiply and get a negative 5x squared plus 4x squared is a negative x squared. I then get my minus 20x. Now on the next one, I'm going to end up getting a 5x cubed. I then have a negative 12x squared minus 10 minus 2 more is negative 12x squared. I then have a positive 4x minus 75x, so that's going to give me a negative 71x. This is getting uglier and uglier as we go, plus our 30. Okay, that numerator is all over, and I'm just going to go for a little bit of speed here, blah, 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 the same thing. When I then simplify that top, I now have my 6x cubed minus a 13x squared minus a 91x plus my 30, and that is all over x squared minus 2x minus 15 times an x squared minus 5x. Now, that would be us reflexing through 5/6 plus 1/9. Okay, we get a common denominator of 54, so I need to multiply that top by 9. I need to multiply that top by 6. We then go through and we clean that up, and we end up getting a 51 54ths, and there's our solution. Now, I'm hoping when we take a look at the blue, we go, hey, that blue's going to reduce, and you can see that you could divide top and bottom both by 3. Well, take a look at the gold. Does that gold fraction reduce? And really what I'm trying to get at in this instance is, depending on your factoring ability with that numerator, you may not have the ability to reduce that fraction. Unless you can factor that 4-term polynomial on top, then you might not have the ability to then to reduce the overall fraction. And so maybe using that blue method to go through and try to simplify that may cause a problem. You may have created a situation you don't have the means to solve. So I would argue to you that I think that gold solution, although correct to that point, really is an inefficient solution. Okay, I'm going to get rid of the whole thing. Well, now when I get rid of that gold, if I'm not going to try to tackle that solution that way, how else could I tackle it? Well, for everybody that says, well, when you have your 5/6 plus your 1/9, just get the lowest common multiple. Like, easily, that has a denominator of 18. My challenge to you might be, what's the lowest common multiple of my algebraic denominators? Maybe not so easy to see. Like if I said to you, well, what's the lowest common multiple between x squared minus 2x minus 15 and x squared minus 5x? You might be saying, what? But maybe if we take a look at that and we say, well, rather than going through and considering the denominator in its entirety, that what I can do is factor. My top is an x plus 4. But on the bottom, if I was to factor that trinomial, I notice I would get that. And if I was to look at the components or factors of the other denominator, now I can see what's in there. So, similar to me taking a look at the other two and saying, hey, there's a 3, a 2, and a 3, and a 3. Hey, wait a sec. My common denominator, my lowest common multiple, has to have all the factors of each denominator. I need to have a 2 and a 3 and 2 3s. And so if you look at the green factors that I've put a star underneath, my 3, and my 2, there's my 18. So really, by factoring that denominator, I can see that I need to have an x minus 5 and an x plus 3, but I don't need to multiply the entire other denominator to find my common denominator. I just need to make sure that I satisfy the factors of that. And so if I notice, I already have an x minus 5 in the denominator from the first denominator. So the only thing that I'm missing now is another x. So I'm going to include that, and for proper form, I'll write my monomial out in front. Okay, take a peek. If I underline in red, you can see the whole first denominator. And if I underline in blue, you can see the whole second denominator. That's how I get my lowest common multiple, which ends up being my lowest common denominator. And now by doing that, I only have to multiply the first numerator by an x. I don't have to multiply it by another x minus 5. I'm keeping my expressions as small as I can. Now I only need to multiply the second numerator by an x plus 3. And now when I go through to simplify each term on top, expand in my x, expand out my brackets, I get a plus 15x minus 2x is a plus 13x. On the denominator, I have all my key factors. I'm just going to wrap up around the side here so I don't have to shrink it down anymore. That gets me to a 6x squared plus a 17x minus 6. And now you'll notice this looks significantly different than my first gold fraction. I don't have a cubic on top because I was able to not blow things up through multiply by choosing a poor common denominator. Now you could take a peek on top, and chances are your skill level with factoring is pretty comfortable with quadratics. That you have the means to be able to check the numerator to see if it factors, to be able to divide out any more common factors, and fully simplify your fraction. Okay, I want you to take a look at that solution in its entirety and notice that is a different methodology than maybe what you use for adding fractions. Okay, clearly, if you are really fast at doing the blue fractions up in the top right corner, then get your common denominator of 18. Really fast. Lowest common multiple. Simplify. But you may end up having a feeling like you're doing something different for the other. There's a process to be able to go through. I hope it helps you out with your practice. I also hope it helps you out with just some general theory for why we do what we do. Okay? Best of luck.